So we've got one more application of quadratics to look at. This time we've got William and his stock portfolio here, where V is the value of the portfolio in dollars and T is time in months. That's important because we're not used to really dealing with months. So first question asks, what is the y-intercept and what does it represent? Remember, to find the y-intercept you plug 0 in for x, so 3 times 0, well, t in this case, because that's our independent variable, 10 times 0 plus 500, so we get 500. Our y-intercept would be 0, 500. So what does it represent? Well, that's the money at the beginning, so I'm going to say that is William's initial, and it was $500 investment. Does this problem have a maximum or a minimum? Well, looking at our a value being positive and looking at our parabola, we can say that this has a minimum. What is it and what does it represent? To find the vertex in standard form, we need to do opposite b over 2a. So t equals opposite b, so negative 10. The opposite of that would be positive 10 over 2a, 2 times 3. 10 over 6 simplifies to 5/3, so our minimum is at 5/3 something. And in order to find our y value, we plug that back in, so we've got 3 times 5/3 squared minus 10 times 5/3 plus 500. 5/3 squared is going to be 25/9 times 3. We are going to get 8 1/3 minus 16 2/3 plus 500. So that's going to give us $491.6 repeating. So since this is money, I will want to round to hundredths because that would be my cents in this case. So if it's 0.66, then when I round up, I will get $491.67. So this represents after 5/3 months, so I'm going to say 1 2/3 months, or you could just say 1 month. After 1 2/3 months, so somewhere between month 1 and 2, William has $491.67 in the account. And that's the least amount of money he'll have in that account. What are the x-intercepts and what do they represent? Well, in order to find the x-intercepts, we can do completing the square, but I would rather do quadratic formula, so since I'm making this video and you're not, you're stuck with quadratic formula. Negative 10 squared minus 4 times 3 times 500 divided by 2 times 3. So 100 minus 4 times 3 times 500 is going to give me negative 5,900 over 6. Do you remember what this negative does? It means we're going to have an imaginary value here. So since this is going to be an I, 10 plus or minus anything with an I over 6, this whole number is going to be imaginary. So are my x-intercepts? They are imaginary. Okay, go ahead and simplify that probably so we could actually get a more specific number. 59,000. Let's see what that splits up into. We can divide it by 100. And 59. 59 is prime, so that's all we can get. 100 divides by 10 and 10, so there's a pair that I can drag out. So it would be 10i squared to 59. these can all divide by 2. So my x-intercepts are going to be 5 plus or minus 5i squared roots of 59 over 3. So they are imaginary, and they are 5 plus 5i squared roots of 59 over 3, 0, and, oops, that should be in parentheses, 5 minus 5i squared roots of 59 over 3, 0. So they're imaginary. That represents William will never have, and this y value, remember, is his value of his portfolio. He will never have $0 in his portfolio. Wise investing, William. Next, we're asked what a reasonable domain and range would be. Domain, remember, is going to be x values, and our x in this case is t, so it's time in months. So probably the least amount of time would be 0 months. And then how long might William leave his money in here? I don't know. Probably years if it's actually making, a good return. And then the range would be the amount of money. So how much money? Well, we found our vertex, this being the least amount of money he's ever going to have, $491.67. And then what's the most amount of money he'll ever have? I'm not sure. So I'm just going to put thousands. Predict the value of William's stock portfolio after 2 years. If 1 year equals 12 months and I have 2 years, so 2 times 12 gives me 24 months. So that's going to be my x value. Put that in. 3 times 24 squared minus 10 times 24 plus 500. Okay. 24 squared is 576. So 3 times 576 minus 240 plus 500. 3 times 576 is 1728 minus 240 plus 500. When we calculate all of those together, we are going to get $19,088. So William's stock portfolio will have, oops, not $19,000, $1,988, $1,988 in it.